Download this code from codegive.com, link in the description below. OK, let's dive deep into JavaScript error handling, covering the core concepts, techniques, best practices, and providing plenty of code examples. Introduction: why error handling matters. Error handling is a crucial aspect of writing robust and maintainable JavaScript code. Without it, your application might crash unexpectedly, provide misleading information, or leave users with a frustrating experience. Proper error handling allows you to gracefully recover, prevent your application from halting abruptly when something goes wrong. Diagnose problems, provide meaningful error messages that help you, and others, understand the root cause of issues. Maintain stability, ensure your application remains functional even in the face of unexpected situations. Improve user experience, present informative error messages to users instead of cryptic failures. Types of errors in JavaScript. JavaScript has built-in error objects that represent different types of errors. Understanding these types can help you handle errors more effectively. The core error types, inherited from the error object, include error, the base object for all built-in error types. You can also create custom error objects that inherit from error. Eval error, represents an error related to the eval function. Note: eval error is not often used in modern JavaScript because eval is generally discouraged. Range error, indicates that a number is outside an acceptable range. For example, using an invalid range for number. To precision. Reference error, occurs when trying to use a variable that has not been declared. Syntax error, indicates a syntax error in your JavaScript code. These are usually caught during parsing by the JavaScript engine. Type error, occurs when an operation is performed on a value of an inappropriate type. For instance, trying to call a non-function or accessing a property of null or undefined. URI error, indicates an issue with the encode URI, or decode URI, functions. The try, catch statement, the foundation of error handling. The try, catch statement is the fundamental mechanism for handling exceptions in JavaScript. It allows you to isolate a block of code that might throw an error and provide a way to gracefully handle that error. Syntax explanation one try block the code inside the try block is executed. If an error occurs during the execution of this block, the JavaScript engine immediately jumps to the catch block. To catch block the code inside the catch block is executed only if an error occurs in the try block. The error variable, you can name it whatever you want, is an object that contains information about the error that occurred. It will have properties like name, the error type, message, a description of the error, and sometimes stack, the call stack, showing the sequence of function calls that led to the error. 3. Finally block, optional. The code inside the finally block is always executed, regardless of whether an error occurred in the try block or not. This is useful for cleanup tasks like closing files, releasing resources, or resetting state. Basic examples. Throwing errors manually. You can use the throw statement to manually throw an error. This is useful for validating inputs, enforcing preconditions, or signaling exceptional situations in your code. Best practices for error handling in JavaScript. 1. Be specific with error types. Throw and catch specific error types whenever possible. This allows you to handle different error scenarios differently. Using custom error classes is a great way to achieve this. 2. Provide meaningful error messages. Error messages should be clear, concise, and informative. They should help you, or someone else, Understand the root cause of the problem. Avoid generic or cryptic messages. 3. Handle errors at the right level. * Don't catch errors if you can't actually handle them. If you catch an error, perform some action, log it, display a message to the user, retry the operation, or rethrow the error to allow a higher level handler to deal with it. 4. Log errors. * Log errors to the console, a file, or a logging service so that you can track and analyze issues in your application. Include relevant information such as the error type, message, stack trace, if available, and any relevant context. 5. Avoid silently catching errors. * Don't just catch errors and do nothing. This can mask problems and make it difficult to debug your code. Always handle or rethrow caught errors. 6. Use finally for cleanup. * Use the finally block to ensure that resources are properly released, regardless of whether an error occurred. 7. Consider asynchronous error handling. * When working with asynchronous operations, example promises, async/await, you need to handle errors differently. See the sections below on promise and async/await error handling. 8. Global error handling. * Implement a global error handler to catch unhandled exceptions that might occur in your application. This can prevent your application from crashing completely. 9. Test your error handling. * Test your error handling logic to ensure that it works as expected and that errors are handled correctly. Write unit tests that specifically test error conditions. 10. Don't overuse try, catch. * Avoid wrapping every single line of code in try, catch blocks. This can make your code harder to read and maintain. Use try, catch only where it's necessary to handle potential errors. Error handling with promises. When working with promises, especially with the fetch API or other asynchronous operations, error handling is critical. There are a couple of ways to handle errors in promises. 1. Catch, method *. In this example, we use response.ok to check if the HTTP request was successful, status code 200 to 299. If not, we throw an error. The .catch method at the end of the chain will catch any errors that occur in any of the .then blocks above it. 2. Then null error handler, less common. You can also provide an error handler as the second argument to the .then method. However, using .catch is generally preferred because it provides a more readable and consistent way to handle errors at the end of a promise chain. Error handling with async/await. Async/await makes asynchronous code look and behave more like synchronous code, which can simplify error handling. You can use try, catch blocks with async/await in a similar way to how you use them with synchronous code. In this example, the fetch data function uses async/await to fetch data from an API. The try, catch block in fetch data handles potential errors during the fetch operation. The process data function calls fetch data and also uses a try, catch block to handle any errors that might occur. Global error handlers. JavaScript provides mechanisms for catching unhandled exceptions at the global level. This can be useful for logging errors and preventing your application from crashing. 1. Window.1 error, browser. In web browsers, you can use the window.1 error event handler to catch unhandled exceptions. 2. Process.on, uncaught exception, node.js. In node.js, you can use process.on, uncaught exception, to catch unhandled exceptions. Important considerations ***. Window.1 error ***. Can be unreliable in some cases, example with cross-origin scripts. Returning true prevents the default browser error handling, which might include displaying an error message to the user. *process.on, uncaught exception, asterisk. Using this to attempt to recover from an uncaught exception is generally not recommended. The state of your application is likely to be unknown, and attempting to continue execution can lead to unpredictable behavior. It's often better to log the error, perform cleanup tasks, example closing connections, and then terminate the process. Summary. Error handling is essential for building reliable and maintainable JavaScript applications. By using try, catch blocks, throwing custom errors, handling errors in promises and async/await functions, and implementing global error handlers, you can create code that is more robust and resilient to unexpected situations. Remember to follow best practices and test your error handling logic thoroughly.